Now you can see here, now we are going to use the feature which is divide command, right? So first of all, I'm just going to create one line segment here. You can see there, I'm just giving the line segment, the size of the line should be there is 100, which is 100, make it fit to screen. And after that you can see there is nothing behind the line. You can see there, I'm just moving the object and now there is nothing behind the line, right? And after that I'm just going to create one more line segment like this. The size I'm giving here is 25 millimeter. After that you can see there, the next value I'm going to give here is 3-point arc. So the first point is there, the second point I'm going to give like this. So now after that I'm just going to create J feature and now make it 1. So these all are 1. Now I'm just going to use the feature which is called divide command, and there is measure command. Point have we done? No. What is point feature basically? PO is a shortcut of point. Now first of all, point we are going to create. Here we can get the point 2, 3. You can see the simply the smaller dots there. These dots are called points. We can change the appearance of the point also by having the short key which is point style, and the short key of this is DDP type. You can see I'm just using the DDP type operation there, and now click OK, and you can see the preview of the other point style is there. This is like cross and various operation as there. So I'm just going to use this operation which is cross. Click OK. So you will see all the point will be coming according to this, right? So short key is DDP type. Now you can see there we have one more option there which is divide and point measure. So here div is the short key of divide command, and now we are just selecting the object which we want to make divide. After that it is asking you enter the number of segments. So the number of segments I am giving here is around 10, and you will see the line will get 10 points on it, right? And after that I'm just going to use the distance. I don't know what is the distance between them. So you can see there, if we have given here the profile and now we have just divided this profile, after that you can see there the distance between them. I don't know what is the distance, and I have not given. It is just showing you that 10 points will be there on the line at the equal distance. It will be adjusted automatically. But if I want to give the distance between the items, so I can go for the option which is called ME. ME stands for measure. So now provide the same object, and now it is asking you specify the length between the segment. So the length I am going to give here is 10 millimeter. So on this profile all the point will come at the distance of 10 millimeter, and as much as the components will fit here, it will fit according to that, right? Same distance. The distance will be 10 millimeter because we have specified the distance, not the component. Number of items we have not specified. It will be created accordingly. So this is the feature which is called divide and measure. And after that you can see there the donut option is there, DONUT. Donut is basically created to give kind of symbols for electrical designing and civil designing also. So here you can see kind of circuit designing and startup and endpoint we can define with the help of this is the operation which is called donut. So the short key of this is DO enter, and here it is asking you to provide the inside diameter of donut and then outside diameter. First of all it is asking you inside diameter, so provide the value which is 5 millimeter, and asking for the second diameter which is outside diameter. So I am just giving 10 millimeter. So simply it will show you the donut. It is not 3D basically, it is kind of 2D element. You can see there I am just orbiting the screen. You will see it will show you like this. So again I am going to top view, so it will show you like in black color. So that is called donuts, and we can specify inside and outside diameter which can be same or which can be differ or which can be into multiplied by 2, double the inside value. And now the next operation there is helix. Helix is basically not completely a 2D profile. We can say it is working on the Z axis also. Obviously it will work on axis Z, right? So helix operation is there. Now the short key is HELIX, helix, and now it is asking you to specify the center point of the base. So center point I'm going to specify here is 0, 0. So now we can see there it is coming somewhere. I don't know where it is coming, so just leave it. Now it is asking for the base radius. If I don't know the radius, I will show the diameter. D enter is a shortkey of diameter. Now it is asking for the diameter. So diameter of the spring I need to have. Spring, basically we are going to create here some spring. So now it is asking for the diameter of base. I am giving the value is around of 20 millimeter, like this, 20 millimeter. And now after that we can see the top radius it is asking. That was a base. Now it is asking for the top. So top also I need the diameter, and now we can see there it is showing you the value, the previous value or the defaulted value. Now I need the value, which is, if I want same parallel, it should be 20. If I am giving the lower than 20 value, it will be like taper, right? So I am just providing the value which is 20. So top radius and bottom radius are same, so the profile will like parallel, straight. And now we can see there it is asking you turn height, turns, axis endpoint and twist. So here I am just going to use the turn height first of all. Turns, first of all we see there how much turns are there. So T on enter is a shortkey of turns. So by default turns are 3. So I am giving here the turns, number of turns should be there is 20, or we can see 10 turns I need to have. And now it is asking you the height of helix. If I have given the value which is 200 millimeter, so you can see if we have given the height is 100 millimeter, then we can see the length of the between each turns. You can say that is called pitch value. That will be 10 millimeter each. But now if I am giving here H, enter, H for turn height. So here I need not to give the complete height. I am just giving the number of height between each one. Only single one I am giving here is around of you can say 15 millimeter. So 15 into 10, that will be around 150. So the height has been defined. Now just use Z enter, E enter for zoom in, zoom out or zoom extent, and after that just make a isometric view. So you will see there, from here you can create the isometric view, SW isometric, and you will see the height is 150, turns are 10, and the distance between each turn is 15 millimeter. Any doubts here? So by this way we can get the spring or helix. Again I am just going to create one more helix here, HELIX. After that it's asking you for the base point. So we have just specified the base point like here. Now it is asking for the diameter or radius, so we are defining the radius is around of 50 millimeter. So it will be like this. Now it is asking you for the top radius. So top radius I am specifying less than 50. So that is I am specifying is 30 millimeter. Now it is asking for the turns height, or turns we have specified are 15. Now total height I am specifying there is 300. So you will see the spring will come like this. Each and every input has been given here, right? So by this way we can get the operation which is called helix. Next operation there is wipe out revision cloud, and this is called 3D polyline. But 3D polyline we cannot use in 2D. We will accomplish this 3D polyline in 3D, but now I am just showing you because we are in SW isometric. Whenever we are in southwest or southeast, isometric view should be there. Whenever you are going to work on 3D polyline now, so you will switch the window to isometric, not 3D basically, should be isometric. 3D polyline should be there. So you can see it is same like line. The shortkey of 3D polyline is 3P. Now provide the first point and make F it on, should be orthographic. You will see there, this is the coordinate system UCS. It shows you the direction. This is the one direction, which is X. I'm just going to give the value 100, and upwards I'm giving which is called Z direction, and the size I'm giving here is 100, and now I'm going to get 100 again in X. Now I'm going to work on Y, minus Y. So here the value we have to specify is 100, and now I'm going back again. Here the value I'm giving is 100. Downward the value should be there is 100, and now after that give the value 100. So you will see it will be like in 3D. So this is not a 2D model now. 100 we have specified, and after that 100, and downward 100. You will see it has been closed. Now this is a 3D polyline. Any doubts here? And this has worked in all three directions. So this is kind of 3D polyline. Any doubts here? So use the 2D top view. So this 3D polyline will look like rectangular, right? So just delete all these segments here accordingly, and now just go for UCS icon, enter, and for no origin, and then click on enter. And after that we have the operation which is called revision cloud and wipeout. So use REV cloud, revision cloud. The shortcut of revision cloud is REV cloud, and after that REV cloud. So just use the revision cloud, but before starting you can see there are three operations there: arc length, object, and style. So what is the arc length? I am giving A enter for arc length. Arc length is 10 millimeter minimum. So I am just giving the value which is 10 is minimum, and maximum I am giving here is 20. And now style, what is the style basically? S enter for style. There's two style here, normal and calligraphy. I am using normal here. Now provide 1 point, and just don't click on the mouse, just drag the mouse. If you are going to the first point, it will get closed automatically. It is like bubble or cloud type. We use this operation just to highlight something, just to highlight some text. So again I'm just going to use REV cloud. Now we can see the style, and now calligraphy option I'm going to use. So it will be looking like this. The thicken profile will be there. Style has been changed. Any doubts here? And now after that, if we have just created some object here, ellipse we have created, you can see EL enter, provide the first point. The second point I'm giving is 500, comma, and after that giving 500, enter. Sorry. Here we have given 200, and you will see you have created the ellipse here, right? And now I'm just going to create this ellipse, convert this ellipse into the revision cloud. So use REV cloud, and now after that use O enter. O stand for object. Pick the object. So this object has been converted into revision cloud. Any doubts here? So we can write inside anything. The writing operation we will accomplish in our next session, right? So these things we have done, which is revision cloud, and now here is wipeout. Wipeout, what is wipeout basically? If we have just drawn here something, we are just opening the file, the previously saved file. You can see we are just using this layer file, right? So now these all are my one file. I don't want to show the line, the second line, this line and this line, the second line and the third line. Sorry, 1, 2, 3, 4, 5. So second and fourth line I don't want to show. so I can hide that. I need not to delete all the time, so just use the operation which is called wipeout, right? And in wipeout you have option which is frame and polyline. So first of all I'm just using wipeout, and now click on this. F8 will not work with this command. We have just clicked inside and now clicked here, now clicked here, and click enter, and you will see the second line has been disappeared. It is behind the block but will not show up. Again I am just going to use wipeout, and now pick this like this. Any doubts here? So this has been converted like this, but now you can see there the boundary is visible, which is making something odd, right? So I'm just going to hide the background boundary as well. So just use wipeout. Frame option is there, the short key of frame is F, and now make it off, so the boundary will also not be displayed. If you are getting the printout of this, only 3 lines will be there, not 2 lines, right? So 2 lines will be invisible. If I want to get back, then you can use wipeout again, then F enter for frame, make it on, and now you can use delete operation. Just select this and delete. Again I'm going to use, and you can see if I'm going to use again wipeout operation and using frame operation, one more operation is there, the third one, which is display but not plot. Matlab means whenever you are going to plot this drawing now, means print this drawing, then the rectangle will not show up, only block will be shown off. You can see if I'm going to get the printout of this, I'm showing you the preview. You will see the rectangle is not coming. Done. Now if you see there, I'm just going to use wipeout and F enter. Now they are on. Then you can see if you are getting the printout of this. You will see the rectangle will be shown. Before that, extension. You will see there the rectangle will be there. Any doubts here? So that's it. That was the use of wipeout. Just make it delete. The original component will show up. Done. So all these features we have accomplished, and now these all already we have done. So drawing bar has been now finished.